Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximize, minimize and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
What's up, everyone? Welcome back to part 2 of Microsoft Azure Virtual Training Day, DevOps with GitHub event. In this next session, we're going to learn how we can work to improve the build and deployment process for Tailwind traders. We're going to learn how we can ease and control the deployment to the cloud, to Azure. Finally, we're going to wrap this entire learning journey up with learning how we can improve the notification and response, as well as improve build consistency and repeatable automation. Now, it's no surprise that security and compliance are core concerns for organizations. Adopting DevOps practices and delivering software faster can increase those concerns. Now, there's key steps we can take to increase security and compliance as part of our DevOps lifecycle. This is what we're going to focus on in Module 4. Let's check it out. Hi, everyone. My name is Jessica Dean, Senior Cloud Advocate at Microsoft. And today we're going to learn how easy it is to build in quality to our DevOps process. Now, real quick before we dive right in, let's do a recap of this DevOps learning path, or learning journey, as I like to call it. First, we learned how easy it was to get started with DevOps. We learned about what DevOps actually is. Then we built on top of that and we learned how easily we can manage the flow of work. Finally, we ended the first part with how we can deliver that change. Now, today where we're at is where we're learning how we can actually build in quality. That's this session. And then as we talked about, we're going to wrap all of this up with learning how we can operate software in the cloud and how we can continue the journey after we're done delivering our DevOps pipeline. Now, let's just go ahead and level set and define some clear goals for this session. First, we're going to learn how we can consider security and how we can handle secrets. Then we're going to learn how we can apply that security to containers, right? We're in this world of microservices and abstracted systems, and security sometimes gets overlooked, or honestly, there's a lot of confusion that falls around that. And we're going to learn how easy it is. And then we're going to end all of this with how we can build quality and gain confidence in that quality that we have built. Now, by now, you've probably seen this Tailwind Traders website. Right? It's a simple front end. We have ASP.NET. We have React built into it. There's some services that are in the background in Azure. This is going to be the same website that we work with today. And we're going to learn how, again, we work with it in containers. So just a quick overview of how this actually works. Right now, we have Tailwind Traders in a Docker container running an app service. It still connects over to Azure SQL Database and Azure Cosmos DB. But there's a few things that Tailwind Traders needs. Certain things aren't quite working the way that we need for scale. First, we need to increase the level of quality we have, especially with the growth that we've recently seen. We need to have confidence in that quality that we're building, especially that we're now in this container world. There's a lot of things that we're not quite seeing, and we need to be able to have confidence in that. And most importantly, or also in a line with equal importance, we need to also have security. We need to make sure that we're still embracing security despite our move to the cloud and our journey with DevOps. So what we want to end up achieving is having our Tailwind Traders website more abstracted. And this isn't just a Kubernetes or Docker or container thing. This is more of an architectural design. We're going to abstract out our framework. We're going to go from this monolithic application. We're going to decouple our APIs, and we're going to start having microservices with backend APIs and web frontends. In fact, when we're done with this, there's 11 different microservices that now we have to manage. Now, this is going to empower and enable our developers to be able to react that much quicker, to be able to debug just one broken API. Maybe it's the shopping cart, maybe it's the products database or the login. But now we'll be able to focus on just that one component. And even though everything's decoupled, it's still going to correspond with our same SQL database that we have in Azure and our same Azure Cosmos DB. So let's start off with the first part, security and vulnerability management. How do we handle this in this new world? First, it's no secret that when we start having different packages and different NPM packages or NuGet packages, if we take it from the source, if we take it from whatever our upstream is, there's going to start being something that we don't understand. There's going to be some vulnerability that might be hidden in there because we haven't had any kind of control or we haven't had any kind of insight into what actually is the life cycle or the history for that package. This is where we get to tie in GitHubs to this. GitHub offers community-powered security and compliance. It gives us dependency insights where we can actually see that history for that dependency for that package. We get things like real-time inventory. We can see license compliance. Is it that this package actually is in compliance with the licenses it claims to have, or is something else going on in the background? We even can get vulnerability alerting. We also get to take advantage of vulnerability management. Now, this is super cool. We get to take advantage of code scanning, secret scanning, so we can make sure that we haven't accidentally embedded a database connection string or plain text password or something like that in our packages or in our application that's now running in production. In fact, GitHub Actions offers the largest vulnerability database. We're even able to set up and configure, if we want, automated security updates. Finally, we're also able to take advantage of CodeQL, which is the world's most advanced code analysis. It actually allows us to hunt vulnerabilities, and it's built with community. Community is a key focus here. We take top security experts and we're able to improve the security and compliance and confidence that we have in the security. Confidence is going to be a key theme you hear throughout this module. So first, with vulnerability management, there's actually over 62 million security alerts that are sent across GitHub. And we get to have visibility and insight into this right from within our GitHub project, within our GitHub organization. Code scanning, as we talked about, allows us to find and fix vulnerabilities fast. We talked about the community of security experts, and it's integrated with developer workflows that we're already using. Since Actions is built right into our repos and our projects, it's very easy to turn on and enable. So let's go into a quick demo where we actually check out how simple it is to get started with both GitHub secret scanning, vulnerability management, and even taking a look at Azure security when it comes to containers and container images. The Tailwind Traders technical team is settling in on their new tooling. Work is moving across their boards, as we learned in the previous module, and now we're starting to get a sense of accomplishment after looking at these boards. But unfortunately, all is still not well. There have been several instances where new releases were deployed with vulnerable container images or missing settings flat out. In fact, in certain instances, we actually found passwords and database connection strings. Certain things were actually embedded and baked into those images as well. The team's leadership as a whole is also worried that since we're now moving at a quicker pace, since we're now able to sprint that much faster, are we really taking the time necessary to review our code as thoroughly as we need to? Or are we sacrificing code quality and doing defensive coding in the name of cycle time and just trying to hit that deadline? In an effort to address these concerns, our team is going to investigate what we can do. We've identified that the first step is to turn on the security features inside of GitHub. By turning on dependency alerts and things like code scanning, we're able to target two serious problems we have. For one, we target outdated dependencies. Two, we also target common security practice violations in our code. Now we can couple that with Azure Security Center and vulnerability management for scanning container images, so we can actually sit there and say, okay, great. We've identified these outdated dependencies, but we've also coupled that with vulnerability scanning. And so we can actually say that this package or this dependency is unsafe, or this image is actually running as a root user and we need it to run as non-root. We can also use Azure Key Vault so that in the event that for whatever reason, a plain text secret of some sort gets baked into something, we can quickly and easily remediate and recover. So we're also going to tie that into GitHub secret scanning so that we can prevent that kind of security issue. In this first demo, I want to walk through the basics of how easy it is to add GitHub security features. Then we're going to walk through Azure Security Center vulnerability management, and we'll even take a quick look at just how easy it is to rotate secrets using Azure Key Vault in the event of exposure. Now, this is especially important because Tailwind Traders, as you've seen in previous demos, in previous modules, is written in .NET and React, and we previously saw both were used in one web-based application. However, when we decouple it and break out the app into more of a microservice architecture, now we've broken out the APIs. We've designed it as 11 different microservices, which means 11 different images and 11 different possibilities for failure. So let's go ahead and take a look at this demo. First off, I have the Tailwind Traders backend up. And you'll notice if I actually drop into the deploy folder, you're going to see how I have a Helm folder. I have ARM templates folders, I have demos, I have different components in this repo. But specifically in Helm, which is the de facto package manager for Kubernetes, it's how we're easily deploying each one of these APIs, these microservices, and therefore each associated image. We can see we have the cart API, the coupons API, the image API, the login API, and all these different services, 11 different ones total, all kind of broken out. Now, if we go back up to the root folder and we take a look at the source, we'll see that we also have code base that lines up with those same services as well. If we simply drop into the services folder, here we have again our cart API, our coupon API, our image classifier, and so on and so forth. So we really want to scan everything in here. And after we take our Docker files and our Helm charts, which reside in the root directory, you can see one right here, of each service API, we're going to want to make sure that we also scan those images to make sure that nothing is baked into them, to make sure that there isn't anything vulnerable in them. But first, we want to start with code scanning and dependency scanning. So there's actually a few ways we can get started. First, if we click on the Security tab, one of the things we can do is set up a security policy. Now, this is going to define how users should report security vulnerabilities for this repository. And what I really like is when you click on Setup and when you actually click Start, it gives you a nice little markdown sample. And if you just want to preview what that sample looks like, you can actually sit there and identify which versions have been vetted by the security team or by your vulnerability scanning as being supported or not supported. Now, if we go back over to the Security tab, once you define your security policy, you can take advantage of security advisories. Now, this repo doesn't have any, but I want to show you what security advisories look like in the context of a real-world project. Let's take Helm, for example. It's an open source project. We have companies around the world that contribute to this project. And as a result, it's also an area where there can be a great deal of security concerns. So if we take a look at the security concerns that currently exist for even projects like Helm, you can see any known security exploits. You can see that there's a plugin archive directory traversal, which versions are affected. You can identify publicly to your repo and to your project which versions are patched, which security concerns were identified, and the severity level. If we go back, we can see that we also have two more. So for example, if we take a look at the CVE here, you can see that this has a high severity level. This is one of the great features that's, again, built directly into GitHub that you can then utilize in your project. Now, if we go down further in the Security tab, you can also set what's called Dependabot alerts. This is a way to get notified when one of your dependencies has a vulnerability. For example, when we click on Enable Dependabot Alerts, you're now guided over to the Security and Analysis part of your project settings. You can either click on Security and go there, or you can click on Settings and navigate to Security and Analysis. Either way, you can enable Dependabot alerts and you can opt in to easily upgrade non-vulnerable dependencies, which means you can have GitHub actually take care of that upgrade and that security remediation for you. The last thing I want to highlight in GitHub is code scanning, which is where you turn on code scanning, which will automatically detect common vulnerabilities and coding errors, which help us be more proactive as we develop. You just simply click on Setup Code Scanning, which is in public beta at the time of this demo, which means you might have to sign up for the public beta. But once you do, you'll be able to set up different workflows. This actually works hand in hand with GitHub Actions, and we'll learn a little bit more about GitHub Actions in our final demo in this module. Now that we see all the different security features that exist within GitHub itself, let's take a look at how that would actually translate after we turn these security features on, after we build our images and then push them over into Azure. Now, I also have my Azure portal up here, and I already have Azure Security Center enabled. I've already drilled down into recommendations, and under recommendations, you can just type images and you'll be guided over to the option where you can view your vulnerabilities in Azure Container Registry images that Azure is recommending should be remediated. Now you can see that I have 10 different repositories that are unhealthy and one repository that is healthy. That equals the 11 total microservices. You can see that some of my repositories have multiple scanned images, which is why, for example, over here, 3 images have been scanned that have vulnerable images versus maybe the cart API that says only 1 image has been scanned. However, in any one of these scenarios, you can drill down into the actual service itself. You can see which package or which digest and which tag was scanned, or the findings, in this case that it's red, which means we know that it has one high vulnerability. If it's medium, it would be orange, and low should be yellow. Either way, we can drill down into our digest and we can actually begin to investigate what the concern is. First off, if we actually zoom into our security check here, we can see that number 1, there's a user with a blank password. And the Linux image also has a hard-coded credential. We can drill down even further to get even more insight into the actual problem. And I can see right here that the image actually has a null password for the user, for the root user in particular. Now, if we were to do simple changes, such as ensuring our container images are not allowed to run as root, we can then mitigate and solve that problem. And we can go through the recommendations for any one of those repositories within that particular container registry. We'll talk about how we can do little things to fix that and ultimately result in a healthy repository like we have with the one healthy repository that's for the popular product API, where there aren't any kind of vulnerabilities. In fact, you don't even get to drill down into the digest because there's nothing to investigate since it's just considered a healthy image. Finally, the last thing I want to show you in this demo is Azure Key Vault. Now, if I navigate to Azure Key Vault resource page, you'll be able to see in the overview, you can see monitoring, requests, latency. But what's really important here is actually on the right or the left. If you drill down into secrets, you can see any secrets that you have. Here's a database secret, for example, for Tailwind traders. You can see the current version. I can actually create new versions based on new secrets. But let's talk about what happens in the event data is compromised. You can set activation dates, which means you can say all database strings for 10 different APIs can activate or need to activate on this date at this time, as well as you can set when those same strings or passwords or secrets expire. You can very easily roll in and either enable or disable those secrets. This is really helpful so you don't have to worry about having your real secret in plain text. Now, this secret can be anything. It can be a database connection string, a certificate, or really any secret. Your secret is backed by this new rotatable and easily mitigated, secure way of retaining your secrets. All right, wasn't that just fantastic? Talking about security and talking about how easy it is to just enable those little features is probably one of my biggest passions, because again, it gives us now confidence in this application we're building, but most importantly, the value we're delivering. So now let's talk about container security, because we briefly touched on that right at the end of that demo. Now, let's do a quick refresh on how Kubernetes architecture works, because to support these 11 different microservices and our abstracted APIs, we now have kind of increased or changed how we have our architecture, how we have our infrastructure. So Kubernetes in a normal scenario, maybe something that's not cloud, something that's not running in Azure, or maybe it is, but you didn't have your cloud provider set it up. It's something that is what's called self-managed. You're going to have your self-managed main node or nodes. So this is kind of interesting because you can have 1 or 3. It depends on how highly available you want to make it. But in either scenario, that main node or nodes is going to have an API server. It's going to have an etcd database. It's going to have a scheduler, and you can have multiple schedulers. It's going to have a controller manager. It's going to have a cloud controller. This is kind of like the brain of your Kubernetes cluster. And then you have what's called your agent pool. These are sometimes also referred to as your worker nodes. Your worker nodes are going to be what's actually running your pods. And the little containers that we build run inside of pods. Some pods can have more than one container. Typically, you will probably have 1, but sometimes you can have 2. But either way, those pods are working because of the Docker engine or the container runtime. In this instance, we're using Docker. This is your agent pool that's now communicating with that main nodes. We can also call the main node or nodes your control plane. Now you're going to have a Kubernetes API endpoint that you're going to have to send some sort of workload or instruction or definitions off to that then is going to communicate to the control plane, and that control plane can then communicate properly to the agent pool. And then we have us as the user, and the user is going to take that app or workload definition. It can be a manifest.json file, it can be a simple YAML file or a collection of YAML files, or it can even be a Helm chart, which is personally, and also from Microsoft's perspective, the recommended way to hand that workload definition off over to your Kubernetes API endpoint. But as you can tell in this self-managed infrastructure, there's a lot of moving parts. There's a lot going on, and there's a lot that can go wrong. So how can we increase confidence in this process? Well, first, we can let Azure take care of the control plane. We can have an Azure managed control plane, which is what Azure Kubernetes Service is. So now you don't have to worry about hardware upgrades or canonical upgrades or anything like that. Instead, you as the user, whether it's the developer, the operations, or whatever your role is, can send off that workload definition, hand it on over to the Kubernetes API endpoint. Azure will take care of it and then schedule it accordingly to your agent pool or your worker nodes. Simple, right? Now let's do a quick refresher also on how container layers work. And this is important when we consider that container security. You're always going to have a base image. In this instance or this example, we have from Alpine. And then each blue block that you see or each block building on top of that is a layer. That's usually a line in your Docker file. All of those layers that gets baked into your image are image layers. They're read-only. Your read-writes actually happen at the container layer when you're running your container, be it you're running it in Docker or Kubernetes. But people forget, and even I've forgotten sometimes, that anything that's in your read-only is accessible at that container layer. That means things like your database connection strings, your SSH key pairs, your plain text passwords. So there's certain things that you want to consider as you're dealing with this, again, container building process. You can think of it kind of like a cake or a stack of waffles. And I like to compare containers to a waffle because all waffles do in reality is they're delivering some sort of happiness or joy. If you take the breaded part of a waffle and you just have it completely plain, chances are it's not going to deliver as much value, unless that's your preference, and that's great, but as much value as if you start adding value-add toppings. You add whipped cream, you add syrup, you add strawberries, blueberries, pecans. All of those different toppings are value adds. You're being very intentional with what you're putting on that waffle, and that waffle now becomes a delivery mechanism for that happiness or that positive end user experience. That's the same thing that a container is. But if you have a stack of waffles or a stack of cake as you see on the screen, you need to be very careful what you're baking into that cake or into that waffle. Okay, this is where it just kind of becomes very important to consider that, to be very cognizant of that throughout your build process. So in this next demo, we're going to learn how we can do just that, how we can be very intentional and how we can build secure containers.
All right, so in our last demo, we saw that we have quite a bit of vulnerabilities that Azure Security Center helped us identify. So now we're going to take a look at the source itself and see how we can start fixing some of those. So the first API I'm working in, and we can actually drop down, you can see that I have Tailwind Traders backend open here. I'm in the source directory. You can drop down into services, and I'm currently working in the cart API. We have all the different APIs here, so we can start working in cart and coupon and image classifier. But I just want to change a few of them just so you can kind of see what we're going to work with here. Here's our Docker file. It starts out with our from image, which is kind of like our base image. We set a work directory, which is the folder that we want to work within our container. And remember, a container is not a virtual machine. A container isn't even a real thing. All it is an application delivery mechanism with process isolation. It's just going to help you deliver your application in the most valuable and safest, secure, most optimized way possible. But that kind of is dependent on you and how you structure your Docker file, right? You have to make it secure. You have to make it perform well. So we have to do things that's going to be optimal for our application delivery. So you can see our work directory, we're copying our package.json file over. This is obviously a JavaScript component of our application. Like I said, it's both coupled as React and .NET Core, but it doesn't matter the language. It matters, again, the structure of that application or that process isolation delivery system. So after we set up our packages, get any of our build dependencies, Python files, we copy our files and everything over, we're then going to run just our normal npm start command, and that's what we defined in our package. Package.json. So right before we actually start our container itself, right before we run it, we're going to add in one line that's called a user. And this is where we can set the actual user name that we want this to run as, or we can set the user level. If we set that user level to 1000, that's just a standard default non-root user, and that helps set us up to make sure that this container is not going to run as root. It's not going to run as a super user, and therefore it won't be flagged in Azure Security Center as a potential vulnerability. The other benefit for this is when you do have containers that run as root, they have the potential, in the event that there's malicious code in your application, of actually jumping out of the container and attacking the host. That is a little specific to Linux containers. If you're working with Windows containers and you have Hyper-V isolation, sometimes you have an additional level of security, but rather than focusing on the architecture from a wrapper perspective, you can focus on the security from the inside perspective, right? Doing best practices so that we can set ourselves up for success. So I'm going to do that on the cart API. I'll drop down, I'll do that on the coupon API and just a few others. You can see again, this is still Node. Right before the command, we're just going to do the same thing. User 1000, we're going to go ahead and hit save. Now, in certain applications, you might find that this isn't enough, right? Maybe you do have to do a little bit more, but taking the information from our vulnerability report allows us to go in and really see, is this something that we can implement, or how can we better mitigate this potential security flaw? I'll do it again on our image classifier and drop down into our Docker file here. You can see this one is actually .NET Core, but we'll still drop down. This is actually an interesting image, so you can take a look. First off, we're setting some arguments. That's why you see arg right up here at the top. We have our SDK tag, our runtime, our image. All of those are arguments that we're setting that we can actually change at build time. We can use the build-arg flag to override that, or we can hard code it in our Docker file as we're doing. And then we're actually using what's called a multi-stage Docker file. So this sets us up for even a greater success or even more additional success. This is just our base image. This is going to be what we actually need to start building our application or our dependencies. A lot of times what we need at build is not what we need at runtime. So we can have a safer and more secure image when we implement multi-stage Docker files, so long as it makes sense for the architecture of the application. We can build our actual DLL file prior to ever running it, and then at runtime, all we need is the runtime software, right? We don't need the actual SDK and the entire package. We can slimify or slim down that image. So you have our base image where we're just going to set everything up for what we're going to need. We pass that off to our build image. So now we're going to take our from and we're going to actually create our build DLL files. We're copying everything over from our build props directory, our build directory. We're setting a project working directory, and then we're actually running our .NET restore and our .NET build commands. And notice this line right here on line 26, this part where we do -o/app, we're putting that output in /app. And that's important because when we get down to not only publishing, we're again putting that in -o/app, but specifically our final layer. This is our final image. This is actually, these 5 lines right here is actually what's running in the container. You can see from base as final, we're going to copy from /app. So we're copying what we built and what we published. And then we're also copying our model files from our build. Any one of these, the build that we have or published corresponds to the name of whatever the name of the stages. So we have publish right here, and then we have build right here. So we're copying the output from that and then just running our application. So now our image is ridiculously slimmed down as opposed to just having all of this baked into one. So right before we actually run this, we can put down here that we're going to set that to user 1000, and we'll simply hit save. Now we could keep going on down the list and do this for all the others. Just to show you the point and show you how healthy images look, let's go ahead and start checking in these Docker files, check in any of the ones that we've saved. add this, and we're going to say update to non-root permissions. And we're going to go ahead and check this in. Now, once we check this in, we actually have a pipeline in play, thanks to GitHub Actions, that's going to go ahead and handle building all of these images and actually pushing them over into Azure, where Azure is going to automatically scan those images and see if we've resolved some of those identifying factors, right? Some of those identifying problems. So let's flip over to GitHub Actions and let's go ahead and watch that kind of build, and then we'll take a look at Azure Security Center. All right, so here we have our pipeline running. You can see that it's still finishing up, pushing some of the last of our images, but it built our new images that we just updated. It built our cart API, we worked on our coupon, we worked on our image classifier. It's just going down the list of all the different images that are associated with the microservices. And on each task, and we'll talk more about this pipeline and what this GitHub Actions workflow is doing in our next demo, but each task in particular is not only building our images, but it's also pushing it over into Azure Container Registry where it can be scanned. So for example, you can see on how it's going through and it's building each one of our stages. Specifically, if we take a look at line 49 in the logs here, you can see right there where it's building that user 1000 layer within our Docker file. So let's hop on over into Azure Container Registry, specifically in Security Scanner, and take a look, or Security Center, pardon me, and take a look at the images that now exist. If we drop down into our registry itself, we'll see all 11 of our repositories that correspond to all 11 images within our application itself. We can drop down into the cart API, and you'll notice now that we have an unhealthy image. We still have one unhealthy image, which was from a few months ago. But if we click on the healthy image tab, we now see that we have a healthy image, which is now from today's date, that has been added. That's because we were able to mitigate and solve that security concern that we identified in the first demo. If we drop back up to our registry and we click on, let's say, our coupon API, you can see again we have two scanned images. There's one vulnerable image out of two, so we have that unhealthy image. But if we click on the healthy image, you'll notice that the image is now showing as healthy because we removed that image as running as a root user. We can drop back up and let's just see, it looks like image classifier hasn't updated yet. You can notice on the right hand side, we're getting a 50% yellow or positive, or 50% high severity or bad. So let's go ahead and click on image classifier and see. Now it could be that there's still more problems we have to mitigate here, right? It actually has identified 3 unhealthy images, including the most recent. So we can actually drop down into here. And actually, if we take a look on the right before we drop down, you'll notice previously we had more high severity than we did any of the medium concerns. Orange is medium. But now we actually have only one high severity concern, and a majority of them are now medium. So we can drop down into that and see why, see what changed. If we take a look, the root issue now should have been solved. And this also, the image classifier is also the .NET application. So now we notice that a lot of the concerns are actually, again, medium severity. You can see that right here, but they're Debian security issues. So we could fix that even more by maybe converting our image base from Debian over to something like Alpine, where it is a smaller attack surface. So it does tend to be more secure, but that's not necessarily the right answer for every single application and architecture. But this is the information that we can take, go back to the drawing board and continue to tweak and make those changes.
All right, now we're almost to the end of this module here, but let's talk about how we continue to build on top of this and continue to build and gain our confidence. First, let's talk about how we can have an end-to-end code-to-cloud DevOps experience. GitHub Actions offers us the ability to build, test, code, plan, monitor, operate, deploy, release. We can deploy anywhere, whether it's on-prem, it's in Azure, it's AWS, it's Google Cloud Platform, it's completely elastic, it's fully managed, and best of all, it supports all operating systems for CI/CD. Now, GitHub Actions, as we've kind of talked about, will allow us to automate. We can increase our automation right from within our project. We can build, test, and deploy with confidence. There's that word again. And best of all, it's customizable with commands that you're probably already using, especially if you're already handling your deployments from Azure CLI, which is also cross-platform and available for Mac, Windows, and Linux. You can tie your Azure CLI commands right on over into GitHub Actions without doing any extra hard work. So in this next demo, we're going to learn how we can use GitHub Actions as well as Visual Studio Code so that we can gain DevOps confidence with containers, infrastructure as code, and even tie in Azure policy.
All right. So here I'm currently looking at my GitHub Actions workflow. It's my full CI/CD for this demo. In fact, we can see on the left-hand side 3 different stages: our deploy infrastructure stage, our build images, and our deploy microservices. In the next session, we'll learn a little bit more about our actual deployment and delivering this code. But for now, I want to show you just a little quick overview on how we were able to build in not only quality but confidence when it comes to our infrastructure, everything we've talked about with Azure policy, with Security Center, vulnerability management, and Azure Container Registry. We were able to take care of all of that in the deploy infrastructure stage. We were able to do so using the Azure CLI commands that we would use normally if we were manually typing those commands in. We simply logged into our Azure CLI or our Azure subscription, and then we were able to go through and create things like our resource group, our virtual networks, our subnets, all of our backend infrastructure. We were able to actually deploy using an ARM template so that we could make sure everything would get applied properly, including Azure policy. We could configure application insights so that we could monitor our application. We were able to create our databases, any virtual nodes we needed, the namespaces for our applications to get deployed. And then we simply went through and built our images as we would normally. This took care of all of our APIs and our gateways. We simply used Docker. And then finally, the last service was actually deploying out our applications onto that infrastructure we deployed in the first stage. Not only were we able to use Helm to install all 11 of our microservices, but we also could take care of labeling our pods for network policy. We could copy our images over to Azure Storage. We could make sure every single thing we needed for Tailwind traders was handled appropriately through a GitHub Actions workflow. And the best part is every time we run through this workflow now, we can make sure that our infrastructure, our applications, everything are deployed so we have confidence in that quality, and the job completes in under 14 minutes. It's pretty fascinating. Now I want to talk about, in the middle of this abstraction, how do we still have confidence in debugging applications? What if there were a problem? What if our code did not have full quality? How do we debug a single API in the context of a larger application? Let's take a look. All right, so I'm currently working within a single API. I'm working within the Cart API. And I'm going to use an extension in VS Code called a local process with Kubernetes. This is going to allow me to debug this one API in the context of the larger application. I can drop down into modules, and I can drop down into my shopping cart JavaScript file. Now I can also click Kubernetes down at the bottom here to actually navigate to the Tailwind Traders application. And I can walk through and start shopping, start using the shopping cart. You can see I've added some items to the shopping cart, and I click Add to Cart. Only there's a bug. There actually seems to be a problem in our shopping cart because every time I go and try to add an item, it doesn't matter what it is, I get a single red guarding gnome. So we're going to actually use our debugger, our actual JavaScript debugger, but with Kubernetes, thanks to that extension, and we're going to be able to debug this problem in the context of the larger application, even though we're only working within one API. So when I actually use my normal debugger, it would launch the program at port 3000 or whatever port I specify on my local system. Instead, I'm actually redirecting that traffic now over to Kubernetes in an isolated environment. So now I can troubleshoot this problem with confidence and work on having quality code. You can see that now the debugger has been connected, and I'm currently using container port 3001 available on my local host at port 3000. 3001 is what's set actually in our Docker file, which is why that's what's running for the service in Kubernetes. We're just using the local debugger on my system at port 3000. Now I can drop down into that shopping cart file and I can actually start debugging as I would normally. I'm going to take a look at the different functions I have, and I see an add item asynchronous function right here on line 51. I can actually set a breakpoint on the return so I can see what it's actually getting for that doc value. Now I can navigate to my isolated instance of Kubernetes. If I click Jessica D, we'll actually notice on how now I have a prefix of my own private isolated URL, and then the ultimate 5E6D, that's the fully qualified domain name where I was accessing the application earlier. So this Jessica D is my isolated version. When I click Add to Cart, now I can hit that breakpoint that I set. And I can use IntelliSense in VS Code to actually see the call stack and what's being sent over to that request, what that value is. And I can see a single red guard gnome is definitely being what's sent. Now I can go back to the debugger and check the call stack. I have add item, process, but I see another function, add product, that's actually in a routing JavaScript file. So I can see here's where I have the const for doc, scroll up, I see the full add product function. And it looks like I'm supposed to be using requests, but I'm not. Somehow in testing, I actually hard-coded a const for a body call, and I actually hard-coded single red garden gnome. So what we need to do is update the const for item equals body to actually use the request.body or req.body. So I'll make that change right here on line 24, and then I'll comment out the const body just so that way we don't have any issues. I'll save that, and then we'll restart the debugger just to make sure everything is clean and kosher here. You can go back over to shopping cart. We'll leave the breakpoint set on our return doc so we can make sure we use that IntelliSense. We'll refresh our browser here and go ahead and click Add to Cart again. Sure enough, I hit my breakpoint, and now I can use IntelliSense to hover over and see what the call was or the detail product, and now it looks like it's sending the proper information. It's sending microwave, 9 cubic feet, whatever that is. We can go ahead and continue on. It looks like it successfully added that to the cart. I now see microwave in there. Let's go ahead and clean everything up in the cart and just get rid of all the garden gnomes and their microwave, and we'll test this one more time. There we go. Go ahead and remove the breakpoint now. Refresh, go back over to try to buy a coffee maker, click Add to Cart, and sure enough it says Coffee Maker Red has been added to cart, and there's our Coffee Maker Red. So now I've built in quality, right? I have confidence in what I've done, but how do I make sure the rest of the team has the same level of confidence? How can I make sure that they have quality, and how can we quickly get this out into production? For one, I'm going to work on my own branch, Jessica Gnome Fix. I'm going to check in my changes. I'll give it a quick message of Gnome Bug Fix. We'll commit and we'll push. And thanks to GitHub Actions, we can actually make a pull request and have a pull request workflow in place. So we'll go ahead and make sure that we merge this into my repository because this is my fork. Make sure I'm merging the right branches and click Create Pull Request. As soon as I do that, there's going to be a workflow that's going to fire off that's going to start building this single API container. It's going to take the single Helm chart for this particular API. It's going to deploy it into its own namespace, into its own pull request namespace for us to test the same change. And not only did I get a local fully qualified domain name or isolated environment through VS Code, but we can also take advantage of that using GitHub Actions to where everyone on the team can also have an isolated preview URL where they can go and verify these same changes. You can see as soon as the PR workflow finishes, you can see there's the private version where now it says Jessica-GnomeFix, period, and then the fully qualified domain name. Now, every single person on the team, regardless of if they speak code, if they don't speak code, whether they're an engineer, a designer, a PM, everyone gets the same level of confidence, and therefore everyone gets to have confidence in the quality we have built.
All right, so now let's just do a quick, brief summary. What have we learned throughout our time together? First, we've learned how easily we can enable and handle code scanning and dependency alerts. We can even set automatic updates to update our packages in the event that there are vulnerabilities discovered. We learned how important it is to build secure containers, but most importantly, we learned how we can build those secure containers. Finally, we took everything that we learned in the beginning and we were able to continue to build on top of that, continue to gain confidence, and we were able to gain what one of my coworkers, Abel Wang, likes to say, DevOps nirvana. But really, we were able to gain DevOps confidence. So now we're confident that whatever we're delivering to our end users is having that continuous delivery of value, is having that positive end user experience, and most importantly, it's also reliable, right? If you want to learn more about everything we've talked about today, you can head on over to microsoftlearn.com, and we have interactive training, we have tutorials, we have sandbox environments. There's so much information you can gain from Microsoft Learn, and best of all, it's entirely free. Wow, that was absolutely amazing. We accomplished so much. We learned how easily we could improve Tailwind Traders' environment management, how simply we could use GitHub Actions for code security, vulnerability scanning. We could even use it to handle our infrastructure as code as part of our continuous integration, continuous delivery. We learned how to build secure containers, and most importantly, how we could have confidence in everything Tailwind Traders built. We're now going to take a 10-minute break, and we'll see everyone back here when we start Module 5. All right, everyone, welcome back from the break. Now, Tailwind Traders has come so far in their DevOps journey. They're now working as one unit between development and operations teams, even as they continue to grow. This is fantastic. But DevOps doesn't stop when you deploy. Incident response, identity management, and controlling access to production are all part of learning to run software well as well. Now, this next module is going to focus on how we can handle just that. Let's get started with Module 5. Now, welcome to the Tailwind Traders team. You've already been on this team. This is Module 5. We've been doing this. But welcome back, and let's take a look. Let's just remember the Tailwind Traders application and how much we've accomplished throughout these modules, right? We were able to first get our application into the cloud, into app service. We were able to decouple our application into several microservices. We were able to get it running in Kubernetes and Azure. We were able to tie in security management and all these wonderful things, right? So what exactly is next? Because we've deployed it. Well, first on our agenda is we're going to make sure that we have a responsible incident response set up. If everyone is responsible for incident response, then no one actually is. And we'll talk about what that actually means. Now, sadly, there's no magic people or machines. We can't just go in and click a button and turn on all these different features as we were able to with a lot of things that we've learned throughout this learning journey here. So we're going to need to consider secrets, passwords, authentication. All of those things need to make sure that we have limited dependencies on specific humans, right? We can't just give everyone the keys to the kingdom or God mode. We also want to make sure that we're considering tooling over tasks. Rather than having humans be the bottleneck or the people doing manual processes, maybe there's certain things that we can actually automate, that we can help solve the problems more simply and free up the resources on our team. Now, even Jeffrey Snover, who's actually a technical fellow at Microsoft, and he's the creator of PowerShell, he has said a big message. He has said, in a lousy economy, nothing, and absolutely nothing is more important than automation. Productivity equals career security. So if we don't automate everything we can, and I'm going to repeat that, automate everything you can, not automate all the things, just everything we can, then we're going to be destined for failure. We're going to be destined to not be productive and not have career security. So we're going to learn why automation is important and how simple it is to automate simple tasks. So first, let's just recap and end this entire learning journey out with a refresher on the definition of DevOps so that we have clearly defined goals with DevOps. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. And this is a quote by Donovan Brown. He was my boss, but now he's my boss's boss. But either way, this quote has been written in books. It's been used on stage. It is now the de facto definition of DevOps for Microsoft. And the most important word in this definition is value. Because if you're not delivering value, what are you doing and why are you doing it? And as we've learned throughout this journey, we've learned how we can not only deliver value, but how we can have confidence in that value. Now can we have confidence in what we're doing after we're delivering that, everything that happens after we've run our pipeline. So it starts with planning, as we've learned, developing, delivering, but now we're at the operation part. We're at the stage 4 of this DevOps definition. And another fun fact about this definition that not many people know, unless you've heard it from Donovan himself or a member of our team, Donovan actually spent 30 days working on this definition. 30 full days, so that he could make sure that him and anyone who quotes it could stand behind every single word. So we really want to make sure that we can remember the importance of that continuous delivery of value and including the operational part of that definition. Higher performance DevOps companies, those companies that have embraced DevOps, achieve developer velocity 10 times over. In fact, it's even more than that. They're able to have 208 more frequent deployments, 106 faster commits to deploy. We're able to have a faster time to market, which directly correlates to increased revenue. You're able to have a 7-time lower change failure rate. and over 2,600 times faster incident recovery. And we'll learn how we can handle incident recovery today in this module. Now, you might have seen this comparison or this analogy before, but pre-DevOps or pre-2020, we actually had some incentives that were not exactly fair. Dev and operations were incentivized at one point in time to work against each other. There was this wall of confusion here because developers, it's in our nature to want to be agile. We want to have more change. We want to have our next sprint. We want to continue to iterate. And we just want to keep moving forward because we love developing and we love building. But operations, which I also know a little bit about because aside from being a developer now, I spent 10 years on the ops side. And I can empathize with that because operations actually just wants to keep the lights on. We just want to make sure our servers are up, which actually means as little change as possible, right? So now developers want to move quickly. Operations want to not move at all. It also creates this wall of confusion because we don't understand where the other person is coming from. And it kind of has this catastrophe. By actually using value as the focus, as the definition of DevOps reminds us, now developers and operations can actually work together towards a shared common goal where both sides want to deliver value. We can now have empathy, we can now have understanding, and now we can work on actually that operation part of the DevOps process. So again, we've already seen this a few slides ago. We have our planning, develop, delivering. Now we're in the operation part because we have that shared common goal of value. So let's start with how we can have responsible incident response now that we're all on the same Tailwind Traders team. Disaster strikes. The website is down. Email notifications went out. Of course, email is so reliable. Everyone reads every email. But actually time goes by and the website's still down. We still have a problem. So incident notifications are not broadly distributed. A lot of times that's what people think. Even I've worked on teams where you get a P1 alert or a P2 alert or Sev1 or Sev2, whatever you want to call it, and we just email the entire engineering team. But it comes across as though it's only informational, we're only doing heartbeat or logging, and that's not actually true incident response. Instead, what incident response is they're specifically directed. Which teams or which engineer actually needs to be notified about this alert? What action do you want this engineer to take? And is this in need of human intervention? Or, as we'll come to learn, is this something that we can help tie automation in? So when we're working through establishing a basic designated responsible individual rotation, or a shift, this is pretty much just a fancy term for creating an incident response shift, we want to create a DRI, disaster recovery incidents, schedule using shifts, which is an app in Microsoft Teams, and we'll learn how we can do that. We're going to learn how we can create a logic app, which is really, really simple to actually connect over to that Shifts team app in Microsoft Teams. And that way we can notify the correct disaster recovery individual or responsible individual. And then we're going to learn how we can update the alert action target in the logic app itself. So this first demo, we're going to go through creating a basic DRI notification.
All right, so we're going to start in Microsoft Teams. I have a team instance set up, and I've already installed something called the Shift app. When we click on Shift, you can see that we've already started to scaffold out the week for our team's shifts for incident response. We can take a look at the first shift here. We have it, when we go into Edit, you'll notice that we have it set for 24 hours. We've assigned the responsible individual, Stephen in this case, and we provided a date and time range for his shift to begin. We could add other things like notes or labels. We can add things like breaks, but we're going to keep it simple. Now, once we have our week or whatever time period we need defined, we can simply select the Copy Schedule button, and we can choose the date range we want to copy from and the date we want to copy our selection to. This will include all notes, activities, time off, open shifts, and even groups. Now, in this example, we're able to create the next 2 weeks for our shifts with only having to manually create that first week range. Now that I've done that, I'm still able to make any adjustments or tweak as needed before this is locked in. Once I've designed the shifts schedule exactly as desired, then I can share with my team, and that sharing action will actually lock in the schedule completely. When I opt to share with the team, as you'll notice, we'll just look here and make sure everything looks good. We have somebody assigned on every day. We're going to go ahead and click on Share with Team. And once I do that, I can decide what details I want to share or lock in. I can go by date range. I can share just one of the weeks we've created. I can share both of them. I can choose to share notifications with the entire team, or only those that may be affected by this change. For example, if 2 people swapped shifts. Once it's shared, now we can say that the schedule is officially locked in, and we can begin leveraging it for our other automation. Here we have our Tailwind Traders website, and if we click on our second tab here, this will bring us into our Azure portal, and we can dive into our resource group for this app service. We'll create a Logic app, so we're going to go to Add, and we'll search for Logic. There we go, Logic app, we'll click that. And Logic apps offer actually a super simple way to create a workflow that's going to connect with a lot of different services within Azure as well as other integrations. We're going to start with some basic information, our subscription, our resource group, and of course a name for our Logic app. We'll call it Alerter. After we click Create, we're just going to be prompted to review all the basic information we've entered. Everything looks good, so we'll hit Create again. This is going to take just a few seconds to build. While it's building, we can actually see the deployment is underway. It'll give us deployment details, and just like that, it is already built. When we click the notification that it's completed, we're actually very nicely guided over, handed over to our Logic App Designer. There's a little video introducing Azure Logic Apps. It's going to walk us through, and there's even some common trigger templates that are provided. We'll select the one for HTTP requests because that's how Azure Monitor is going to interact with our Logic app. And one of the things that's interesting is Azure Monitor actually has a specified common alert schema that we can use. We can find that right in the docs for Azure Monitor. We'll just copy that, and then we can paste that schema from the docs over into our Logic app. We'll just add that to the request body. Great. Now, once we get that copy and pasted, we can actually start to build our action out. We're going to add a second step, and this step, we're going to have to pull and figure out who's actually on call. So we're going to search for the connector that's going to connect over to the Shifts app for Microsoft Teams. Here it is. We'll select that. We can see we have a number of actions we could select. We're going to find the one that's going to list all shifts. We can see list all open shifts, offer shifts. There we go. List all shifts. We'll go ahead and select that. Now we have to sign into our Teams account. This is going to persist our Teams credentials and bind them to this connector for our Logic app. Once it authenticates, we can then select which team we want to list all shifts for. So you can see right there under Team. In this instance, we're going to want to choose the designated responsible team. And then we're going to add any parameters that we need for our particular time window. Now, I don't actually care about all shifts. I care about all of them during a particular time block. Since we have 24-hour shifts, the way this action works is it's only going to return the shifts that are fully encompassed in whichever defined time window we have. So we're going to go to our expression window, and we're going to type add days. There we go. Days, there we go. And then in our parentheses, we're going to start taking the time now. We're going to subtract from 1. We're going to go back 1 day. And then we're also going to go for the end time, and we're going to go forward 1 day. So this is going to give us that full 24-hour window for our shift polling. We'll do add days again. We'll do the time now again. And this time we'll do +1. Now, since we have a 24-hour shift, with this expression, we should only get just one shift result returned because only one 24-hour time window is going to be in that time frame. Unless, of course, my incident is happening right at midnight, of course, in UTC time or something like that, in which case we'll probably get 2 shifts returned. And in that instance, honestly, it's okay if I ping 2 people, so I make sure that the incident is still resolved. Okay, once we have our list shift step defined, we now need to add another action to actually iterate over that previous list result, because the list result is actually going to give us an array.
even if there's only one result. We're going to look for a simple for each loop. There we go. And we're going to select the array list output from the previous step. That's what we want to iterate over. From that for each loop, we're going to look and we're going to add another action to get the details about that shift we listed, because we need to know who's actually assigned to that shift. So we'll select get a shift, select our designated responsible team again, and then for shift ID, we're going to go over to our dynamic content option list, and we're going to search for the shift ID, which is going to give us the unique ID of that shift. Great. Now we're going to add another action. And this time we're going to search for Microsoft Teams, that connector itself, not the Shift app connector, just Teams. This is going to allow us to begin to craft our message to that ID we pulled in our previous step. Under Actions, we're going to choose the get@mention token for a user so we can ping that user accordingly. We're going to have to sign into Teams again because this is actually creating an authentication between Logic Apps and Teams as opposed to Logic Apps and the Shift connector. It's just a different way that it authenticates. Now under User, we're going to again search for dynamic content, and we're going to have to see which shift was assigned to the shift ID that we identified in the previous step. So if we scroll down, we'll find shift assigned to user ID. Very simple. And that's going to let us actually look up that mention token for the Teams user we want. Now we're going to be able to actually send the message to the person on call. We'll add an action again. We're going to click on Teams, and now we're going to find the option to post a message. This option is going to actually allow us to post a message as something called the flow bot. Flow is the previous name for Power Automate, and Power Automate, Power Apps, Logic Apps, all of those actually share a number of connections together. They have things in common. Now, 3 of these connections we've used right in this demo. We're going to select the necessary team again, designated responsible. Under Channel, this time we're going to select front-end incidents because this is an incident that's going to happen on our front end. That's how we're going to use this alert. And under Parameters, we're going to choose to start defining the parameters we want. Now this message is going to be sent as HTML, so we're going to paste in a sample message here with using some dynamic content. You can see that we're using our app mention along with alert rule, severity, we'll find the date and time of the alert, the link for where a responder can go get more information, and other general details. We'll hit save, and if we scroll up, you'll see we actually have an HTTP post URL. We'll grab that to our clipboard, and we can use that to send some test data to make sure this Logic app functions exactly as we would expect. Great, so now we're going to head on over to Microsoft Teams, and just like that, you can see we actually have a test alert coming through. This is excellent. This is exactly what we want. We can click the alert. We can see we got a mention for Steven. We can see the data of our alert. We can see that it's a Sev2 issue. We can see the alert time, the number of errors, and the portal link. So now that we know this works, let's do one last thing and wire this app up into our alerting infrastructure. We're going to head on over to Azure and then to our App Insights for Tailwind Traders. We're going to scroll down on the left-hand side to Alerts. We'll click on the Manage Alerts rule right up here at the top. There we go. And you can see that we currently have 2 alert rules in place, one of which is conveniently named Bad Stuff is Happening. Currently, this rule defaults to sending a lame email. Now, the email rule isn't exactly working, probably because no one reads their email. So we're going to select an action group, and we're actually going to choose to create a new action group. We're going to have this alert go to our new Logic app that we just created. We'll again have to give some basic information, a short name for a group. We're going to select the resource group. We're going to name our action. We're going to choose an action type. Now, in our case, our action type is going to end up being Logic app. So you can see right now we're entering a short name. We're making sure that we're in the right resource group. This is very important. And then we're going to name our action name. We'll just call it Logic app. And we'll make sure that we say it's alerts. Under action type, this is where we find, yep, there we go, Logic app, perfect. And now under that, we're going to make sure that the Logic app we're pointing it to, that we're also in the right resource group. And then it's going to automatically be able to go find that Logic app that we just created. It finds it right away. We'll leave the option to enable the common alert schema as is. We'll hit OK. And now we'll have to hit OK a second time for that action group. Once we do, action groups can be used by more than one alert rule, which means we can actually set this up in a generic fashion and we can use it any way we desire. We'll leave the email alert rule as is, it's not hurting anything, and we honestly want to make sure that we're comfortable with how this new alert rule and the logic app behaves.
Wow, okay, so that was a lot, but it was super simple to do, right? We could actually create our shift, we could handle our notifications, we can ping the specific individual who's responsible and who's on call, and we could do all of that by using automation. Now, if certain parts of that were lost or you wanted to figure out where you could go get the common alert schema, as I mentioned in the demo, all of that is available on Docs, where you can actually see tutorials, samples. Docs is really kind of the de facto place to go when you want to learn anything. But if you want to check out aka.ms docs/alert schema, it'll take you right to that resource that we used for our logic app. Now, we mentioned earlier that there's no magic people or machines, right? There's no snapping our fingers or just clicking a magic button. We actually have to identify the problem and really kind of work through it hands-on. So in this instance, a previous engineer recently left for a new role. Several components of the application infrastructure had access control tied to that person's account. And if you've ever been in this scenario, when the person leaves and unfortunately their user role or their account was the one that actually held the keys to the kingdom, now you're going to start having issues. Things won't be able to authenticate. You're going to start having a bunch of problems. So as you can probably expect, this led to cascading failures across our entire Tailwind Traders environment. How do we solve for that? Well, first, we can actually use something called managed identity or Azure managed identity in Azure. This is where we can actually have identity authentication over keys or a user account. By creating managed identities for specific services, specific applications, and then using service principals attached to that identity, we have now removed the service principal from the user or removed the user as a potential bottleneck. We also can tie in managed identity to other things like Azure Key Vault, where we can actually store other secret information, including database connection strings, certificates, and other parts of our infrastructure and security management. Identity in Azure is very important and actually incredibly simple to set up, as we'll learn. So in this next walkthrough, let's go ahead and set up an assigned managed identity together that we'll later learn in our last demo.
Now, setting up a managed identity in the portal is actually pretty straightforward. We simply go on over to our resource. In this case, we've headed on over to our app service. We're going to scroll down to identity on the left-hand side. When we click that, we can see that we have two options. We actually have system assigned or user assigned. We can also toggle this status to on or off. We can enable system identity. We're going to go ahead and toggle it to on. We will then be asked to confirm if we want to enable system assigned managed identity, which we do, so we're going to go ahead and click yes. Now from there, Azure's going to go out and do the rest of the heavy lifting. It's going to go out and create the identity, it's going to give it an object ID, and then we can go and assign role permissions. We can see the identity has already been created, and now we see the button to assign permissions. We can also use managed identities for future things like Azure Key Vault.
All right, again, that's one of my favorite demos because it's so quick, it's so easy, it's so fast. And if you want to learn more about identities, again, you can head on over to docs, aka.ms/docs/identities. We'll go through application registration, setting up service principal objects with your identity, how to handle permissions, how to really build on top of what we just learned with creating the identity itself. Now, let's kind of wrap up with how we can choose tooling over tasks. This is where we start to automate things that maybe people were manually doing or what we like to call heroically doing. They're doing more work than is necessary because it's something that we can, again, build in automation. So another quote from Jeffrey Snover back in 2010, he says, "I can't see the value of automation," or "you can't see the value of automation." At some point, it's just simply an IQ test. It's just a matter of, if you're not getting it, let's set it up. And the first time it goes off, the first time it works, it's like the light bulb goes off of, oh my gosh, this is so valuable. This has just saved me 10 minutes of having to log into the portal, click on my web app, go ahead and restart. Instead, I could automate that with something called chat ops, and we'll talk about that. So as we've built up, we're going to learn how we can reduce manual intervention now that we're in production. We're going to move any kind of manual repetitive tasks over to automation. We're going to start with one. We're going to start with a demo. We're going to minimize the long-term user principal role assignments. So we're going to take that managed identity that we just created, and we've already given it only the permissions that it needs, and we're going to actually use that in our next automation task. We're also going to make sure that it has a central secret store that we're relying on so that we don't have secrets flying around or up in the open or tied to any particular person. So this next demo is we're going to dive right in. We're going to use a logic app, Microsoft Teams, and we're going to create flexible automation to restart our Tailwind Traders web application.
All right, here we are. We're back in the Azure portal, and a common task we might have to do is restart our web application. Let's look at how we can validate that the automation we're going to create is going to be able to handle our restart task. We can head on over to our application logs, and we can begin to search for the last time our application was restarted. Now I can see that I have 2 timestamps for application starts. Great. Now I can pop back over to the app service dashboard and click restart. I'll use the logs to see what kind of message posts when the app is restarted. Now we're going to wait just a few seconds, and then we'll refresh our logs to see what that restart looks like. Remember, we're just using this app as an example to see what kind of tasks we can automate. Rather than giving team members access to our application so they can go do simple things like restart the web application, we can actually leverage automation that's built right into Azure. Okay, now it's refreshing, and for some reason we get 2 application started alerts. Again, that's okay, that happens from the web portal, but at the end of the day, we now know what we're looking for. So let's go back and actually build a logic app that's going to handle this restart functionality. We're going to go back to our dashboard, we're going to click add, we're going to search for logic app again, and we'll click create. We're going to enter all of our basic information. We know to make sure that we want to select a region, we're going to give it a name, we're going to fill in any other information, resource group, subscription, all that looks good. We're going to click on review and create, we'll review it, and then we'll simply hit create. We've done this before, luckily, right? So this is easy. We also know, since we've done this before, that this goes quite quickly. Just like that, it's already succeeded. We're going to go over to that resource. Now, last time we actually used a predefined template, right? We used something to do when an HTTP request is received. This time, we're going to actually use a blank logic app. You can see we scrolled all the way down, and now we're going to search, or we're going to get started with Microsoft Teams as our trigger. When a new channel message is added, we're going to have it do a bunch of tasks. We're going to add some conditions, some if-else statements. We're going to start off with adding the team, designated responsible in this case. We're going to select the channel. We're going to choose front-end incidents again. And now we're going to set how often we want this logic app to pull our Teams channel for information. We're going to set it quite low at actually about 5 seconds. If this were production, we could set it a little bit higher, but for the sake of this demo, we're just going to set it very simple. Now we're going to add another action, and this time we're going to set it to initialize a variable. And the reason why we're handling variables now here with step 2 at the top level is so that we can use them further on down in our action. We're going to use nested conditions, as I mentioned, and when you start dealing with nested conditions and if-else statements, if you haven't actually initialized a variable you plan to use, then it gets quite complicated. So we're going to name our variable reply. And for type, we can choose different types we want this variable to be. We're going to set it to be a string because we actually want it to hold our string or our reply for our text. Great. Now we're going to add another action, and this time it's going to be a control action. We're going to set up a condition, a control condition. This is going to check a few things. First, it's going to check, is this chat message that it received from the trigger for our automation, does this contain a keyword? Is it meant for our automation? We're going to find the message body content option under dynamic content because we want to take a look at the message body, and see if there's a keyword. For example, tailbot in this case is present. We're going to select starts with as opposed to contains, and we're going to enter tailbot as the keyword. Now we're also just going to rename this so that when we're visually looking through our logic app, we know what step this is, especially since we're going to have a lot of steps. You'll notice just by looking at this that this is really just a colorful, glamorous if-else statement. If it does start with tailbot, we'll do something. If it doesn't, we'll do nothing. Okay. Now we're going to go add an action for if true. We know that we're going to need to respond. And I know I'm going to go need to get an @mention token for the user so our action can actually respond to whomever sent the message. We're going to scroll down and we're going to find the option for message from user ID. And we're searching for this because this is going to give us our ID that we can then use. Remember, we kind of used this earlier in the last action or logic app we created. Now, after we have our ID, we're then going to check for the contents of the message again with another condition. We're going to look at the message content again to see now if it contains a string of text. So we'll go ahead and add in another condition here. Again, that's just under control. You can see we have a few different control conditions. We'll add this action under true, because if it contains this new string of text, then we're going to have it do something. So under condition value, we're going to say if the message body, not that message body, scroll all the way down. And don't forget, you can also search in dynamic content, but we're going to search for message body content. And then under here is we're going to say that we want to make sure that it contains the string restart the web front end. So we'll change the condition to, rather than is equal to, we're going to change it to contains. Perfect. Now, if that's true, we want to actually go and restart the web front end. Logic Apps has built-in connectors for working directly with app service. So we can actually go right up here and we can search for app service. Lucky us. Now, the first action, surprisingly enough, once we click on app service and scroll down, first action right there is restart web app, and that's exactly what we want. We're going to select that, and you'll notice that we're going to have to sign in to connect. Now, this time we don't want to use a user ID. Instead, we're going to use a service principal, right? We learned about service principals to connect. This way, we don't have to have any particular user's ID associated to how this action behaves, right? We minimize the potential bottlenecks that we have there. So we're going to need to specify the client ID. This is kind of like the username. We're going to have to specify the client secret, which is kind of like the password, and then which Active Directory to look in. Now, service principals can be used across multiple tenants or across multiple subscriptions. So Azure actually calls this tenants. So we're going to make sure that we specify the right tenant ID, and that's going to set up the connection over to app service. Once we have the connection created, you'll notice from that point, we'll be able to actually start selecting the app service itself. Now we can fill in the details for our web app, which subscription our app is in, which resource group, and the app name itself. Now remember, our service principal that we're using only has rights into one subscription. We can add the action again, and then we'll need to set up a reply since our restart trigger is configured, okay? Now we're gonna set a variable again for this condition, and we're gonna use the variable we created in the beginning, okay? That was that reply variable. So we're gonna go search for variables. There we go. And this time we're going to use the option to set that variable. We can choose the name, and you'll notice reply pops right up. Perfect. Now we're going to have to enter a variable value. And this is where we're going to start tying things together. We use the @mention token, and then we use a set of predefined text. In this case, I have restarted the web front end as you requested. That's what our bot's going to say. Now, if it receives a message that it doesn't understand, that doesn't say restart the web app, we're going to set an if false condition for set variable. This time the reply is going to contain or have a different type of reply. We're going to say I'm sorry @token, I don't know how to, and then we're going to use a regex expression to actually replace the text and grab that part of whatever the user requested that the bot simply doesn't understand. Perfect. Now in either scenario, we're going to add another action. This is because we want to actually send the reply in any scenario, whether it's true or false. We're going to find Teams again, and we're going to choose to post a message. We're going to fill in details before. Again, we've done this several times now. We're going to fill in Teams, we'll fill in our channel, we'll fill in our message ID. We'll just choose the post message, and here you can see Teams, we'll choose designated responsible, we'll fill in the channel, and for message, we can have it be that variable that we've now set. And the beautiful thing is we only have to do this action once because we've kind of set up our if-else statements with variables that are being captured. So all we have to do is reference the message or the dynamic content accordingly, and we're just going to search for that reply variable, and it's going to contain whether it's true or whether it's false. The previous condition will go ahead and act that. There we go. Now we could also add in a subject of the message if we wanted, but we're just going to leave it as is. Everything should be functional, so let's go ahead and save it. Perfect. And then we're going to flip back over to Teams and actually test this out. Okay, now we're in Teams again, and we see our previous alert there. We're going to ask Tailbot to restart our web application. So I'll say, Tailbot, could you restart the web front end? Remember, that was our text that we used for our logic app we just created. Okay, now we're going to wait 5 seconds roughly, which is the time increment that we set, and we can see if this logic app begins to really start enabling this chat ops experience for our team. We're now going to be able to automate simple tasks such as restarting. This is going to free up time and resources on our team so we don't have to manually or heroically go out and do things that really can be automated. And also, since this is happening in our front-end incidents channel, other members of our team can also see that the app is being restarted, as opposed to someone directly having to go and tell someone or text somebody, hey, guess what? I restarted the web app. All right, there we go. Now we can see that the web app was restarted as requested, or at least that's what our logic app bot says. As much as I'd like to trust Tailbot, let's actually go verify that it was actually restarted. We'll head back over to our browser, and we're going to take a look at those logs again. We want to make sure that the application has started again. So we're going to refresh our logs and see what we get. Getting our data, hang in there. And cool, just like that, we can see that there is a most recent timestamp so that we know now confidently that our application was restarted. Now let's test what happens when Tailbot gets a message that it doesn't understand. Remember, this is that false condition that we defined. We're gonna ask Tailbot to go get us some coffee. Tailbot, could you get me some coffee? Which is perfect because I could really use coffee. And Tailbot should reply, and just did, with the message that we told it to use. I'm sorry, it used the @message token to tag the user sending the message, and it says, I don't know how to, quote unquote, get me some coffee. The quotes was where we were able to use that regex expression to actually grab the statement or whatever the request was that Tailbot didn't understand, and it could put that right into the message. Now, of course, we could create a service account for Tailbot to use, which we probably would in a real production scenario. Since we didn't, you'll notice that these replies from Tailbot are actually using the same name of the user, because it's the same name of the user that created the logic app. So take that with a grain of salt. In production, we probably would want to create a specific service account for our app, but now we have confidence that our application or our logic app and our automation actually is working as designed and intended.
All right, let's do a quick review because we've learned so much and it's been so much fun. First, we've learned about how we can handle responsible incident response. We've learned about shifts, we've learned about teams. Again, remember, if everyone's responsible, no one actually is. It's kind of like human behavior. You send an email out to everyone, and it's kind of natural for that whoever reads the email to think, oh, this went out to the entire team, someone else will handle it. It's not going to be my problem. As we've learned, by using DRI, using shifts, and using teams, now it pings a specific person, and that person knows it is absolutely their problem. We know now that there is no magic people or machines. We have to be responsible for secrets, for passwords, for authentication. So we learned how we could actually tie in managed identity and remove the user as a potential bottleneck and remove the potential for catastrophic failure. We also learned how we could let machines do the repetitive tasks, right? We learned how we could do chat ops, how we could tell the bot that we built in Teams to restart our web app, as opposed to having to take 5 to 10 minutes to log in, to click on the right service, to restart, or what happens if we shouldn't even have those permissions in the first place. This way we can make sure we're doing things right and we're using the tools necessary to solve the problems that already exist. Now, for all of the resources for our session, you can check out Microsoft Learn. Again, this is a really great place to get hands-on material. You can actually even check out training for the AZ400 certification. You can head on over to aka.ms, getting-started-DevOps, And then you can even get certified. There's actually designing and implementing Microsoft solutions certifications. If you want to learn more about that, that's at aka.ms/az400-cert. And again, we've just touched on this, but Microsoft Learn, or learn.microsoft.com, is one of the best ways to get hands-on training to go through different modules or learning paths where you actually can walk through everything that we've talked about today. We're constantly adding new modules, new learning paths, and best of all, it's entirely free. Wow, what an amazing journey. This concludes our Microsoft Azure Virtual Training Day DevOps with GitHub event. First, let's recap on all the amazing content you've seen. Tailwind Traders really has been on quite the journey. They've learned what exactly DevOps is and how easy it is to get started with it. They learned how they can easily and efficiently manage the flow of work, how they can successfully deliver change and enable automation for deployments. And then they continued to build on top of those amazing skills that they gained, and they were able to also have confidence in the deployment process, in the security of what they built, both infrastructure and microservice-wise. Finally, they learned how they could refine and improve their DRI on-call process, how they could improve incident response practices, and move many regular tasks, like restarting a web app, over into logic apps, and use chat ops, and use managed identities. Thank you so much for attending, for hanging out with us, for being part of the Tailwind Traders team today. We really hope that you enjoyed these sessions. Remember, there are many ways to continue your learning journey. One of the best ways is Microsoft Learn, where we offer self-paced learning options completely for free. Be sure to check the calendar for more Microsoft Virtual Training Day events, and thank you very much for hanging out with us today.